基因是指携带有遗传信息的 DNA 或 RNA 序列，也称为遗传因子，是控制性状的基本遗传单位。基因通过指导蛋白质的合成来表达自己所携带的遗传信息，从而控制生物个体的性状表现。自从1990年人类基因组计划启动以来，人基因组碱基对的测序工作也接近完成。目前，仅登记在美国基因银行数据库中的 DNA 序列总量已超过70亿碱基对。海量生物数据的积累和基因检测技术的成熟，也为大规模的商业应用奠定了基础。资本开始关注这一前景未知的市场。据预测，如按国内每年5亿人次体检计算，10%人群进行肿瘤早期基因筛查，每人收费3000元，则市场规模在1000亿级别。今年11月15日，美国食药总局批准首个癌症基因检测平台，该平台可以用2代测序的方法检测468个基因的改变，对多癌种进行临床病理诊断。这是美国食药总局第一次批准基于2代基因测序的大基因组合。此前，美国食药总局批准的都是有具体药物疗效或具体变异位点的肿瘤诊断产品，只有少数的个体治疗方案得以进行。这一消息意味着肿瘤基因检测的商业前景更明朗，让中国的基因检测公司看到商业化的希望。第一财经传媒有限公司首席执行官周建功专访美国哈佛大学遗传学教授、益真生物联合创始人乔治·丘奇，为您解码基因工程将如何颠覆未来医疗。
Professor Church, thank you very much taking time to tell us about your research and what does it mean to the future of our human beings' life. My first question I want to ask, can you give me more details about the George Church Institute in Shenzhen, what you are going to achieve?
So we have demonstrated if you change the genetic code, meaning changing every instance of a particular codon in every protein, then you can make an organism resistant to all viruses. This is a very profound idea in that you can make organism resistant to viruses you haven't even studied before, that you haven't seen before, by changing the genetic code. This is brand new in that we will be engineering pigs so that they are resistant to all viruses. This is useful not only for food, but also for transplants of organs between pigs and humans. What we have done in my laboratory is develop certain technologies in bacteria, but it's a very big jump. A whole new set of technologies are needed to get that to work in mammalian cells.
So what does it mean to the medicine, to the food, or to the health of the human being?
Yeah. So right now we have a number of problems with viruses. One is you have zoonotic diseases that is spread from pigs to humans on farms. There are virus diseases that will wipe out farms. And finally, there's when you transplant organs from pigs to humans, which we're just beginning to do, very often the transplantation will be caused by a viral infection. For example, hepatitis in the case of liver. It will destroy your liver. You need a new liver. You bring it in, it gets hepatitis, it gets destroyed. So you want to break that cycle by being able to make organs that are resistant to viruses. So there are three cases: zoonotic diseases, loss of productivity on farms, and organ transplant to help humans.
Sounds very profound.
Yeah.
And genome sequencing as well as the genome editing is very hot in for the science and the technology media. We are always talking about the two technologies.
Right.
We know the Chinese contribute a lot in the sequencing as well as editing.
Right.
Can you give me a comparison between China and America, their advantage and disadvantage, and the future, what their future would be?
Right.
Yeah.
Of course, things are changing very quickly, but so far most of the so-called next generation sequencing has been developed in the United States, mostly in Boston and San Francisco area, a little bit in England. Similarly with genome editing, most of the excitement has been around CRISPR, which is also Boston and the San Francisco area. I think this is for the core technologies. Some of the exciting applications to human disease are happening worldwide. But again, even there, the companies are dedicated to producing gene therapies using editing are concentrated in Cambridge, Massachusetts. So even within a few blocks of each other are 4 major companies, which is Editas, Intellia, also caribou and CRISPR therapeutics and egenesis. China is pulling ahead. I think it really is showing a real leadership. BGI has pulled ahead. Veritas has a big component in China. We're going to be seeing their non-invasive prenatal testing took off in a sequencing mode in China, where now millions of women are getting tested during pregnancy. So all of these things are indicating to a high level of application and innovation in China and sequencing. For editing so far, there's just been a few academic efforts on say embryo editing and so forth, where China has shown some leadership, but so far I haven't seen the kind of commitment that we have in Cambridge, but I think that will come very soon. To some extent, it's more cost effective to do genetic counseling than to do gene editing. If you can prevent the diseases as early as possible, which is done by counseling. So you can get a $600 genome is much less expensive, including counseling, than $1 million gene therapy. So I think that the priorities in China are very good.
基因检测的商业应用主要有2大。学家乔治·丘奇教授将如何看待互联网公司对生物科技的关注呢？
Also, we noticed that other tech giants in the Silicon Valley, for example, Google, pay pretty much attention to this research of genetic engineering and also the medical science. Is it a trend in the Silicon Valley for the tech companies investing money and putting the people into this field?
It's definitely a trend. It's not just Google. I mean, Google is invested in mosquitoes and aging in calico and in brain-computer interfaces. But in addition, Facebook has a brain-computer interface effort. Elon Musk does, and Brian Johnson. They all are interested in this because clearly there will be better ways of brain-computer interface than talking, typing, visual and so forth. So in Silicon Valley, they're all interested in it.
So they're from the Harvard, MIT, the East Coast, right? And Silicon Valley is the West Coast. In China, in Shenzhen, it's also called the Silicon Valley of China. So it's not from the traditional universities or the institute or the hospitals. So what is the future of the genetic science? Future is on the West Coast, like Silicon Valley or the high-tech companies?
Until recently, I would say that Silicon Valley has been so successful at computer, electronics, and internet that they had less interest in investing in biology. In contrast, the East Coast was much more focused on biology. Almost all the major pharmaceutical countries of the world, some sort of headquarters or research laboratories in Boston, and many, if not most, of the startups that were exciting to investors in biotech happened in the Boston area. So there tended to be a divergence where the West Coast was more internet and the East Coast was more biopharma. But now with the brain-computer interface, there's getting a little of that on both coasts, but that's still a minor field on both coasts. Shenzhen will do everything. I mean, it will do all of these.
Does BGI fully fund George Church Institute in Shenzhen?
BGI will certainly be funding a project in Shenzhen.
And how many people and how much money will be involved into this project?
Well, I think that's still, it depends on how well it goes and where it goes, but I would say that their major commitment at this point is towards synthetic biology. I mean, in addition to sequencing the population, a similar level of commitment to synthetic biology, and this is, I think, the most exciting project in synthetic biology worldwide.
Given your reputation in the biology and in the chemistry, a lot of the China's the companies as well as the institution want to invite you to join their effort in the future researches. For example, recently the Damo Academy of the Alibaba put you on board of the advisory. So how would you involve in this project?
Well, the Alibaba Damo project is quite a bit bigger. It's aimed at a number of cutting-edge science and technology, including quantum computing, big data analysis for medicine, and synthetic biology in a broad sense, possibly information encoding technologies, which may also be of interest to BGI. So I think there's some opportunities for interactions, but they were both totally independent efforts, proposed and developed so far independently, but hopefully I can help bridge the two if it becomes appropriate.
Alibaba is an e-commerce tech company, but now it wants to do research in the synthetic biology, like the medical science.
Right.
How would you advise Jack Ma to get into this brand new field?
I think they are looking to stay on the cutting edge and maybe even push beyond where the cutting edge was. There's a long history of this happening clearly in the successful organization range of Microsoft, Amazon, Bell Labs, Alibaba. This could be another totally unexpected technology comes out that can benefit the corporation. I think they're interested in brain-computer interfaces, which is obviously half of that is in the computer field where they're very comfortable, and half of that is in the biological field, the brain. And so they need to have insight into where that's going. And the biological end is now moving much faster than the electronic components. And so it's a very good idea to look at possible synergies between those and to stay on top of the biological revolution.
Okay, can you tell me the most exciting things will happen to the genome engineering, like in 5 years or in a decade?
Well, it's hard to predict what will happen. You could say what could happen as we...
Okay, what could happen?
Yeah, I mean, what will happen will depend upon public will. In other words, what the market wants, what government, what ethicists wants. But what could happen is we have an opportunity of eliminating a number of infectious diseases in developing nations, like malaria in developing nations, Lyme disease in developed nations, that affect millions of people. And we can do that by gene drives affecting the vectors, like the mosquitoes and the mice that spread these. That's a big thing that could happen in the next 5 years. Organ transplantation from pigs to humans could solve the worldwide transplantation crisis. I think we will have these virus-resistant cells that is part of this new initiative could happen as well. I think we're going to see projects like the Personal Genome Project will be producing synthetic biology where we can make organoids that tell us what kind of human genetics causes disease and what doesn't by testing them in human organs in the lab outside of the body. So these are things that will happen probably in the next 5 years in a very big way that makes an impact in society and commerce.
2013年 元人民币的检测费用，而进行全基因检测也不过1万块钱。在企业信息公示系统中输入基因检测，我们发现有3211家公司，其中大约1/3都是在最近1年之内注册成立的。那么，基因检测这一风口是否能够真正彻底改变基础医疗的现状，惠及普通人的生活？请继续收看。
So all those things sounds very exciting, but some of the therapies and the treatments or the drugs would be very, very expensive, right? Especially for some rare diseases. So how could you make it available to a lot of people, maybe in the hundreds of millions, to the not only for the rich countries, but also for the developing countries and poor countries?
I think that's an excellent question. So gene drives is an example of that. That could be even less expensive than vaccines, because with vaccines you have to take a medical staff into every remote village and make sure that every child and adult is vaccinated. With gene drives, you can release it into the mosquito population, and mosquitoes do all the work. That's one example. For gene therapies, I think a more cost-effective approach is genetic counseling. As we bring down the price of the genome from $3 billion now down to 600, that will keep dropping until a point where it's far more cost-effective for everybody to get their genome sequenced so they can avoid the genetic diseases that are so expensive. Genome sequencing could be almost free soon, right? In the same sense that GPS, it costs somebody money, right? Somebody has to put the satellites up and run the cell phones and so forth. But to the individual, it's basically close to free. I think the same thing will be true of sequencing soon, and that will save us the really expensive drugs and sometimes palliative care. You know, just taking care of a sick person for which there is no cure is very expensive, and it's very harmful to the family as well. So preventative medicine in the form of genetic counseling, I think, is going to save us all kinds of money, especially at the end of life, where a huge fraction of the healthcare costs go.
How soon would that happen?
It's already happening. So we already have genetic counseling has eliminated certain diseases in the populations that practice it. So Tay-Sachs and a variety of other diseases have been eliminated from the Ashkenazi Jewish communities. And what's missing is the education that lets people know how much they can save by practicing it. And it could be that we need to do something like had happened with seat belts and airbags, is that we may never be able to convince the consumer. Even though the Ashkenazi Jewish community has done it, we may not convince everybody else. So we may have to just make a regulation like banning cigarettes or making cars safer.
The ethical consideration is always going on along with the genetic engineering.
Yes.
And there are different countries you mentioned in China, America, and also United Kingdom and European countries. They are doing the genome, the sequencing, the CRISPR, and other ways of the genetic engineering. So, do you think among these countries they have a consistent ethical standard or consistent regulations on all those research applications?
Well, I think there are differences from person to person in opinion. When you get to standards at a governmental level and an international level, they're very similar, right? So, for example, the FDA in America and the CFDA in China have very similar regulations now. And each year I think they get more and more similar. The patent regulations have now been regularized. So it used to be America had a different patent system. Now it has adopted the world system. There is variation. I think one of the biggest variations has to do with genetically modified organisms. So almost every nation embraces GMOs for manufacturing of drugs. So you can have bacteria that produce human insulin, that's okay. But the genetically modified foods varies from place to place. Some places love them, some places do not. But in a way, that's acceptable to have variation. You can almost consider it a cultural variation. It's like some people spicy foods and some people don't, right? There's no reason why everybody has to eat the same foods. And I think GM is that something where there's no clear benefit to the consumer, and therefore they just don't develop a taste for them, right? But if they improve the taste, if they improve the nutrition, if they provide something that's life-altering, that would be a different story. But I think for the most part, the regulations are similar around the world, but the ethics can vary from person to person, and they can even vary from moment to moment. You can change your mind on your ethics as you grow older.
Yeah, because those research are so important for the future, for our health and for economy and for some industries. Do you have the concern that some country may have less strict standard or the lower level of the ethical standard than other countries, so that these countries can take advantage to making some breakthrough in this research?
Yeah, I think that the countries that tend to have low standards tend not to make breakthroughs. They often have lower standards because they don't understand science well. And if you don't understand science, you're not going to be making a breakthrough. So I think countries like America...
I mean ethical.
Countries with low ethical standards also have low scientific standards, and so they tend not to make breakthroughs. I think countries like China and America have very high ethical standards. Now, you could argue that capitalism or commerce can be a distorting influence in countries that do have high ethical and regulatory and scientific standards. They can nevertheless have commercial push to go faster. But generally speaking, that's why the regulations are so well entrenched in these countries that have good, strong technology, is that they've had bad experiences. You know, for example, in Europe, they had a bad experience with thalidomide. In the United States, it was with Vioxx. So you have a few bad experiences and you tighten up the regulations. So I think regulations are a good thing. They, in fact, to some extent, they stimulate the creative process of how to satisfy the regulations as quickly as possible.
Sounds very exciting. Thank you very much, Professor Church. Thank you for sharing with me and our audience your insights and thoughts.
Thank you.
Hope to see you more often in China.
Okay.
Thank you very much.
I think you will.
Thank you. Thank you.
Bye.